Now, in the preceding video, I calculated this as if I was trying to find the intercept at 0, 15. Okay. Actually, what was on the board was we were supposed to find 0, 40. Okay. So 0, 40 would have occurred if the number in front here had been negative 40 over 225, which would be like 0.16. It would have given us a graph up here, a little different vertical stretch. Now we're going to go ahead and find the correct result. This is correct if we wanted the y-intercept to be 0, 15. Okay. I just didn't look at this, and I had the 15 in my head, so I kind of messed up. So the logic of this, I'm going to do this a little differently than we did before. Before I said, okay, here's the y-intercept, here's where we want the y-intercept. We've got to multiply by this divided by this in order to move the y-intercept to that point. And of course, we vertically stretch by that factor to accomplish that. Okay? Well, now, we're going to find a polynomial with zeros here and the multiplicities again from here. So, what we know is that P of x is some multiple of x plus 5 squared times x minus 3 squared times x minus 1. And we want to find the multiple, the a. That's our vertical stretch factor. Almost wrote 15 again. So we know that P of x is this, and that we want the y-intercept to be 40. The y-intercept is what you get when you evaluate the polynomial at 0. So P of 0 is 40. So we write this as the equation P of 0 is a times 0 plus 5 squared times 0 minus 3 squared times 0 minus 1 equals 40. Kind of a bad looking A, I'll make it worse. Okay, that's an A. Okay, so it's A times this times this times this equals 40. Well, that's really easy to solve for A, isn't it? So this idea that we write the polynomial with some number out in front representing a vertical stretch of this function that we've already graphed, it's a fairly simple situation. If we write out the condition, it looks like this, and now we only have to multiply this stuff out. So this gives us a times 25 times 9 times negative 1 equals 40. And I know you don't need me to include that step, but I'm going to do it anyway. That's a times negative 225 equals 40. So a equals negative 40 over 225, which is negative 8 over 5 into 225 is 45, which equals, no, wait a minute. Never mind, it doesn't equal that. Okay. So, negative 40 over 225. I was going to write it as a decimal, but it doesn't come out exact, so I'm not going to do that. Thus, p of x equals negative 8 over 45 times x plus 5 squared times x minus 3 squared times x minus 1 has zeros at x equals negative 5, 1, and 3. Well, multiplicity 2 at negative 5 and 3, multiplicity 1 at 3, at 1. So it's actually quite simple. Practice it a little bit, but in practicing it, you don't want to just write it out without thinking about what you're doing, or you won't remember. If you think about what you're doing, it's pretty straightforward. You just think, well, in order to get a 0 at 5, I need to have an x plus 5. And if the multiplicity of that 0 is 2, I'm going to have that 2 on it, because I have to have 2 of them. And I write it out with the exponents. Okay? So this much is very straightforward. It has to be this in order to get the zeros, but you're going to have to multiply it all by something in order to match it up with a given point or a given y-intercept. And notice we could also do this with a given point, okay? So let's do that. If we want these zeros and multiplicities, but the graph to pass through the point negative 2, 25 as before, then p of x is going to be a times x minus x plus 5 squared x minus 3 squared times x minus 1. And p of 2, the value at p of negative 2, the value of the polynomial at negative 2 should be 25. So p of negative 2 is a times negative 2 plus 5 squared times negative 2 minus 3 squared times negative 2 minus 1 has to equal 25. Very easy to find a. This is going to be 3 squared, which is 9. It's going to be 5 squared, which is going to be 25. And that's 225. And then we have to multiply that by negative 3 to give us 675. So negative 675a is going to be 25. A is going to be 25 over 675. There are 4 25s in every 100. If we had 700, that would make 28 25s. So we don't quite have that many. We have one less. We have 27 25s. It's not 27. It's 1 over 27. So our polynomial, which I don't have room to write, is going to be 1 over 27 times this, times this, times this. That polynomial will go through the point negative 2, 25. The graph of that polynomial will go through the said point. Again, straightforward, easier than much of what we've done in the course. But there's an important picture that goes with it.